Have you ever wondered how edge computing works? In the ever-evolving sphere of technology, edge computing is rapidly becoming a buzzword. But what exactly does it mean? In simplest terms, edge computing is a computing paradigm designed to bring data storage and computations closer to where they are needed, at the edge of the network. This technology is revolutionizing the way we interact with data, making processes faster, more efficient, and more secure. Now, why is edge computing such a hot topic? Well, in our hyper-connected, data-driven world, speed and efficiency are paramount. Edge computing has the potential to radically reduce latency, improve network load, and offer enhanced privacy. Furthermore, it's an enabler for a multitude of cutting-edge technologies like Internet of Things, autonomous vehicles, and smart cities, to name a few. The impact of edge computing on our digital ecosystem is significant and far-reaching, and its potential is virtually limitless. So, are you ready to delve into the fascinating world of edge computing? To truly grasp the concept of edge computing, we first need to understand its basic principle. Imagine a bustling city. The city represents a traditional cloud computing model, where all the processing power and data storage are centralized in one location, the city center or the cloud. Now consider the traffic congestion during peak hours. That's the latency and the bandwidth use we face in cloud computing. But what if we could decentralize this city? What if we could distribute the processing power and data storage across various points, closer to where the action is happening? This is where edge computing comes into play. At its core, edge computing is a distributed computing paradigm that brings computation and data storage closer to the sources of data. These sources could be anything from your smartphone to an autonomous vehicle, a manufacturing robot, or a smart home device. By doing this, edge computing aims to improve response times and save bandwidth. Think of it like this. Instead of having to travel all the way to the city center, you now have everything you need right in your neighborhood. You no longer have to deal with the traffic congestion or, in tech terms, the latency and bandwidth use. And it's not just about speed and bandwidth. By processing data closer to the source, edge computing also enhances privacy and security as less data needs to be transferred and stored in the cloud, reducing potential exposure to breaches. So how does edge computing differ from traditional cloud computing? In the cloud computing model, data is processed in large centralized data centers, often located far away from the data source. This can lead to longer response times and higher bandwidth use. But with edge computing, the processing happens right at or near the data source. This not only reduces latency and bandwidth use, but also allows for real-time data processing, which is crucial in today's world of Internet of Things and real-time applications. In essence, edge computing is all about bringing the processing power to the data, rather than the other way around. Now that we understand what edge computing is, let's explore why it's making waves in the tech industry. One of the major benefits of edge computing is speed. In today's world where every millisecond matters, edge computing delivers information faster by processing data closer to the source. For instance, in automated manufacturing, where split-second decision-making can mean the difference between smooth operation and a costly malfunction, edge computing is a game-changer. Another advantage is reduced latency. With traditional cloud computing, data has to travel from the device to the cloud server and back again. This journey, while often just a few fractions of a second, can add up, causing delays that are unacceptable in many modern applications. Edge computing, on the other hand, brings processing power closer to the source of data, significantly cutting down these delays. Imagine a self-driving car that needs to react immediately to sudden obstacles. In such a scenario, low latency isn't just a convenience, it's a matter of safety. Now, let's talk about data security. With traditional cloud computing, sensitive data must travel over networks, increasing the risk of interception. Edge computing, however, allows for more data to be processed on-site, reducing the amount of data that needs to be sent over networks and thus enhancing data security. Consider a hospital where patient data is highly sensitive. With edge computing, much of this data can be processed right at the hospital, minimizing the risk of data breaches. Finally, edge computing provides a solution to the ever-increasing amount of data being generated by devices. Instead of sending an overwhelming amount of data to the cloud, edge computing allows for intelligent sorting and processing of data at the source, reducing network congestion and improving overall system efficiency. Clearly, edge computing brings a myriad of benefits that are revolutionizing industries across the globe. So, what does the future hold for edge computing? As we look forward, the growing trend of edge computing paints a promising picture. It's set to revolutionize the tech industry, making data processing faster, more efficient, and more secure. Imagine a world where your smart devices communicate seamlessly, where response times are virtually instantaneous, and privacy concerns are a thing of the past. However, as with any burgeoning technology, there are hurdles to overcome. For edge computing to achieve wider adoption, we must address issues like standardization, interoperability, and security. We need to develop robust protocols that ensure seamless integration across various devices and platforms. Furthermore, managing the sheer volume of data generated at the edge of the network poses significant challenges. Despite these hurdles, the potential benefits of edge computing are too significant to ignore. Experts worldwide are working tirelessly to innovate and overcome these obstacles. The future of edge computing is undoubtedly bright, but like any other technology, it has its own set of challenges to overcome. So, let's quickly recap what we've learned about edge computing. We began our journey by defining edge computing, a technology that brings computation and data storage closer to the devices where it's needed, reducing the need for long-distance communication and thus minimizing latency. We then dove into the fundamental principle of edge computing, understanding how it decentralizes processing power, placing it on the edge of the network closer to the source of data. This is a game changer, providing real-time data analysis and improving the efficiency of our digital interactions. We also explored the many benefits of edge computing, like improved speed, reduced costs, and enhanced security. It's a technology that's revolutionizing industries from healthcare to gaming to autonomous vehicles. Looking ahead, we envisioned a future where edge computing becomes a staple in our digital world, unlocking new possibilities and driving innovation across sectors. As we continue to produce more and more data, technologies like edge computing will become increasingly important, so keep an eye on this space.